Hello, sir, and my fellow batchmates. I am RAJORSI Sinharay. I am a second year Electronics and Communication Engineering student from Coochbehar Government Engineering College. I am currently going to present a topic which is the modulation in the subject of analog communication. Now, here in the analog communication, the topic modulation, which primarily consists of these types of things: the communication process, block diagram of general communication system, transmitter, modulation, why modulation is necessary, different types of modulation system, demodulation or detection, and conclusion finally. Now, here in the communication process, the elements of a communication system. Now, basically, the fundamental purpose of an electric communication system is to transfer information from one place to another. Thus, electronic communication can be summarized as the transmission, reception, and processing of information between two or more locations using electronic circuits. These original source information can be in analog form, such as human voice or music, or in digital form, such as binary coded numbers or of alphanumeric codes. Now here we can see the block diagram of general communication system, which consists of generally information source, input transducers, the transmitter, and after the transmitter, the channel with the collaboration of noise, it goes to the receiver, and finally receiver to output transducer. And this is about the block diagram of general communication system. Now we'll see the transmitter. The function of transmitter is to process the electrical signal from different aspects. For example, in radio broadcasting, the electrical signal obtained from sound signal is processed to restrict its range of audio frequencies up to 5 kHz in amplitude modulation radio broadcast, and is often amplified. In wired telephony, no real processing is needed. However, in long distance radio communication or broadcast, signal amplification is necessary before modulation. Modulation is the main function of the transmitter. In modulation, the message signal is superimposed upon the higher frequency carrier signal. In short, we can say that inside the transmitter, signal processing such as restriction of range of audio frequencies, amplification, and modulations are achieved. All this processing of the message signals are done just to ease the transmission of signal through the channel. Now here in the case of radio transmitters, a primary example, a cell phone has several transmitters, a duplex cell, transceiver, a Wi-Fi modem, and a Bluetooth modem. These are the example of. And in the laptop computer and home wireless router, which connects it to the internet, creating a home Wi-Fi network, both have Wi-Fi modems, automated microwave transmitters, and receivers operating on 2.4 GHz, which exchange data packs with the internet service provider, that is ISP. Now after transmitter, we are just going to discuss about the modulation, and before that, based on technique used for signal transmission, we can categorize the electronic communication system as under. That is, one of these baseband transmission system, and another one is communication systems using modulation. So here in modulation, so what is actually the modulation is? Modulation is the process of varying one or more properties of a carrier signal with the information to be transmitted. Think of it like this: you have a powerful but bland radio wave, the carrier signal, and you want to send a message, your information like your voice or music, whatever it may be, to Modulation is how you imprint that message onto the radio wave so it can be transmitted and then decoded to the receiver. In the process of modulation, the carrier wave actually acts as a carrier which carries the information signal, that is the modulating signal, from the transmitter to receiver. This is similar to a situation in which a person travels in his car or on his bike before one place to other. The person can be viewed as a modulating signal and the car or bike as a carrier as shown in the figure. Here you can see the example which is described here. The modulating signal, it is with the help of modulator, that is the carrier signal, it helps in the process, and after the modulator the signal get modified into modulated signal. Why modulation is necessary? Efficient transmission, longer distance transmission, multiplexing, noise reduction, signal processing, avoids mixing of signals. These are the main highlighted points. Now we are going to discuss this point in brief. So in the first topic, efficient transmission, information signals like audio often have low frequencies. Transmitting these directly requires very large antennas. Modulation allows us to use higher frequency carrier waves which can be transmitted efficiently with smaller antennas. Longer distance transmission, higher frequency signals travel further and less susceptible to attenuation, signal loss, that is, over distance. Multiplexing, modulation allows multiple signal to be transmitted simultaneously over the same medium, that is, example, radio waves. This is done by using different carrier frequencies for each signal. Think of radio stations, each one has its own frequency. Noise reduction, some modulation techniques are more resistant to noise and interference, improving the quality of the received signal. Now here in the case of signal processing, modulation makes it easier to process the signal at the receiver, such as filtering out unwanted noise, which is quite important in processing the signal. And the final point is avoids mixing of signals. If the baseband sound signals are transmitted without using the modulation by more than one transmitter, then all the signals will be same frequency range, 0 to 20 kilohertz. Therefore, all the signals get mixed together and receiver cannot separate them from each other. Hence, if each baseband sound signal is used to modulate a different carrier, then they will occupy different slots in the frequency domain, that is different channels, we may say. These has been shown in the figure. Thus modulation avoids mixing of signals. Here it is a block diagram of different types of modulation. Uh, in modulation system, it is divided into two branches. That is, one branch represents the analog modulation system and another branch is digital modulation system. So here in analog modulation system, it can be further divided into three categories. That is amplitude modulation, angle modulation, and pulse analog modulation. After, in analog modulation, it is further divided into two categories, that is frequency modulation and phase modulation. And in the other branch, where digital modulation system, it is divided into two parts, pulse coded modulation, delta modulation. In pulse coded modulation, it can be divided into pulse amplitude modulation, pulse width modulation, and pulse position modulation. So it is the total, the branches of modulation. So after that, we are just going to see the each topic in detail. Here in amplitude modulation method, the carrier is a sine wave with frequency f. The carrier frequency is much higher. Here we can see very easily in the diagram. The carrier frequency is much higher than the frequency of the modulating signal, that is f. The amplitude of the carrier varies in proportion to the amplitude of the modulating signal, as shown in the figure. We can see very clearly here what happening just in amplitude modulation. The amplitude modulated, that is AM signal, is transmitted by a transmitter. The information is contained in its amplitude variation. The frequency of the carrier remains constant. AM is used in radio and TV broadcasting applications. These are the example. After the amplitude modulation, we'll just see about the topic of frequency modulation. In frequency modulation method, the frequency of a carrier is changed in proportion with the amplitude of the modulating signal. Thus, frequency compression and expansion will take place in figure. That is the expansion and that is the compression. Here we can see very clearly. The FM signal is transmitted by the transmitter and it carries the information in the frequency variation. The amplitude of the carrier remains constant. Also, FM is used for TV, sound and radio broadcasting and police wireless transmission. After that, here we're just going to elaborate the topic phase modulation, PM, the short form. In PM, the phase shift of the carrier signal is varied in proportional with the amplitude of the modulating signal. The amplitude of the carrier remains constant, thus the information is carried to the phase variations of the modulated signal. The phase modulated signal is shown in the figure. That is that. Phase modulation is very similar to the frequency modulation. The only difference is that the phase of the carrier is varied instead of varying the frequency. Here, the phase of the carrier only vary. That is the main difference. The amplitude of the carrier remains constant. Also, PM is used for generation of FM. Now we are just moving towards the topic of pulse analog modulation. The short form PAM, PWM and PPM. For the AM, FM and PM discussed in the previous articles, the carrier is a sinusoidal signal. However, in the pulse modulation, the carrier is in the form of pulses instead of being a sine wave. In PAM, that is the pulse amplitude modulation, the amplitude of the pulse carrier is varied in accordance with the amplitude of modulating signal. In PWM, pulse width modulation, width of the pulses, and in PPM, pulse position modulation, the position of the pulse is varied in accordance with the modulating signal. The PAM and PWM signals are shown in the figure. These are the pictorial diagram of PAM, PWM and PPM respectively. Now pulse code modulation, PCM, and delta modulation, DM. These are digital pulse modulation systems. Here a train of digital pulses is transmitted the transmitter. All the pulses are of constant amplitude, width and position. The information is contained in combination of the pulses. The digital communication has higher noise immunity than the analog communication system. It is now the demodulation or detection. The modulated signal are transmitted by the transmitter via air medium or wire medium. These signals then reach the receiver by traveling over the communication medium. At the receiver, the original information signal is separated from the carrier. The process is called the demodulation or detection. So basically what it is the separation at the receiver. The original information signal is separated from the carrier. Detection is exactly the opposite process of modulation. So in conclusion, to summarize, modulation is essential in communication systems to facilitate long distance transmission, reduce interference, and enable multiplexing. We explored different types of modulation, including analog and digital techniques. Understanding these concepts is crucial. So understanding these concepts is crucial for anyone interested in telecommunication and signal processing. So thank you everyone for your kind attention. Thank you.